All right, here we go. So this is problem number 77 from Chapter 6 of the Holiday and Resnick textbook. It says, what's the terminal speed? So we're looking for a terminal velocity of a 6 kilogram spherical ball. So our mass is 6.00 kilograms. It's got a radius of 3.00 centimeters, which is the same as 0.0300 meters, and a drag coefficient. So our drag coefficient is capital letter C. That is 1.60, and we know that the density of the air is 1.20 times nothing, 1.20 kilograms per cubic meter. All right, so the trick here is this, that if your object is at terminal velocity, so here's my sphere, my ball, it's got a mass of 6 kilograms, so the idea is gravity is pulling this thing down with a force of 6 times 9.8, so that's negative 58.8 newtons, right? Well, if it's at terminal velocity, that means that my drag force is also 58.8 newtons, right? Because once you reach terminal velocity, your acceleration is 0. All right, that's the whole point of terminal velocity. All right, so once you realize that, this is pretty straightforward. We just use this equation. The equation for drag force is 1/2 c rho a v squared, and just solve for v. V ends up being 2 times your drag force over c rho a, all square rootified. And so you just plug in your numbers. So you get 2 times 58.8 newtons all over 1.6 times 1.2 times, oh, I gotta find the area. Well, the area is just pi times the radius squared. All right, and solve that thing, and you get 147 meters a second. There you go.